Hey, hello guys, this is Shubhabrato and welcome back to my channel circuiTician. In the last video, you have seen that I am making a IoT based RFID home security system, and on that video you have seen that the system block diagram, circuit diagram and the PCB design. So if you haven't watched that video yet, then go and watch it out. You can get the link in the description and the I button. In this video, I will show you the parts I am using in this project, the assembly process and the installation process. So don't skip the video, watch till the end. Let's get started. In this project, the challenging part is designing the gate lock mechanism. As we are designing the gate lock mechanism using servo motor, so we have designed a case for the servo. So after designing, we have 3D printed the servo motor case, and this servo motor case is divided into two parts: the bottom part where the servo motor will be held and the top part which will cover the servo motor. We are using limit switches to fine-tune the end position of the gate lock mechanism. So we have also printed the enclosure for the limit switches. The mounting style of the limit switches are different, so we have printed different type mounting box for the limit switch. But the main concept is same. There is two part for the limit switch enclosure. The first one is the bottom part where we will mount the limit switch, and the top part for covering the limit switch. So these are the 3D printed parts for now, and these are the small limit switches with roller heads which we will mount in the limit switch enclosure. We are using this MG995 metal gate servo because the torque required in this system is high, so for that reason we are using this motor. This is the part which is made out of two metal strips, and in the one end we have attached the servo motor, and the another end will attach to the gate lock mechanism. And here we have used a M4 nut bolt for the free joint, and we will also require some 3mm nut bolts with different head structure. The first one is the chisel type head structure, and the second one is the CSK type head structure, and this one is the Allen type head structure. We will also using some plastic boxes. These plastic boxes will be used for the RFID card mounting and the touch switch mounting, and this is the box where we will mount the main controller unit. Basically this box is a 5" by 5" PVC box which is used for CCTV camera mounting, and this is a 4 ohm 3 watt speaker. We will mount this for our voice indication system, and this is the DF player mini which will help us to develop this voice indication system. Now I will mount the servo motor to its enclosure. First I will bypass the wire from the side slot, and now I will cover the top of the servo motor, and I am using chisel type or chisel head M3 nut bolts. So after mounting the servo motor, we have covered this enclosure with some waterproof tapes to prevent the water damage. Now I will mounting some CSK type M3 nut bolts in the limit switch enclosure. Then I will put the limit switch into the enclosure, and with the Allen head M3 bolt I will fix the limit switch into the enclosure. As our system has lots of wire coming out from the main controller box, so we need some type of connector to connect the wires to the controller box. As I have almost 22 to 23 wires, for that reason I am using a DB25 connector. And for mounting the DB25 connector male part into the box, I am making a slit into this box using a printed stencil. So we have successfully made the hole. Now we are using nut bolts to mount this DB25 connector male part into the main controller box. Now I will mount this 4 ohm 3 watt speaker into this box. For mounting, I am using silicone because it will also prevent the water to come inside the box. Now I am using hot glue to fix the speaker into the box strongly. I have soldered the wire to the reed switch, and now I am mounting the reed switch into the enclosure. Now I will place the magnet into the enclosure box and seal it with silicone because we have to make every box waterproof. I didn't shoot the whole video about PCB making process because there are plenty of resources on YouTube. So I take some pictures and small videos while making the PCB. So here you can see. So after soldering all the components, our PCB will look like this, and this is our main controller PCB. This 2-pin JST terminal is for power, 12 volt power, and this 2-pin terminal is for 5 volt power, and here is the power output for 12 volt and 5 volt together. And this 2-pin terminal is for 3.3 volt. This is for the servo power, and this 2-pin terminal is for the reset switch. Here we have a 6-pin terminal for all the switches like limit switch, touch switch, and here we have a 2-pin connector for the pixel LED, and this 4-pin connector is for the other LEDs and the buzzer. And in this section near the DF player we have two 2-pin JST connector for the sound output, and here we have a 5-pin JST terminal connector for connecting the RFID module. And beside this 5-pin terminal, you can see 2 numbers of 2-pin JST terminal, which is basically I2C pins. But in this project we don't need that, but I just kept it in the PCB for future needs. And here you can see the relay section with the transistor. Now it is the time for the RFID PCB. Here in the RFID PCB you can see the top pads. These top pads is for soldering the wires directly into the PCB. We don't have any type of connectors. So first we have a AMS 1117 voltage regulator for converting 5 volt into 3.3 volt. Then we have a yellow color LED for power indication, and then we have red and green LED for access granted and access denied status. And we have used 330 ohm resistor for current limiting purpose of the LED, and we have male headers where we will put the RFID module. So I have soldered female headers to the RFID module, and I have also soldered the crystal oscillator in the back side of the PCB so we can keep the top portion clean. Now I will put RFID module into the RFID PCB. So our RFID box PCB is ready. Now we will mount this PCB into our RFID box. So I am using this black color plastic box as a RFID PCB holder box. So I made 3 holes in the side of this box, and I have used rubber grommets to pass the wire through the holes because it will tighten up the wires and do not allow to pass the water inside the box. And here is our switch PCB. Basically here we have provision for 2 touch switches and provision for connecting all the limit switch and read switches. So here you can see 4 LEDs, 3 LEDs for the limit switches and 1 is for the read switches, which will allow us to indicate the gate alignment. And here we have 3 pin male headers for connecting the touch switches, and we have also 2 LEDs for each touch switches. Now I will put the touch switches on the top of the male header, and I have also soldered the female header beforehand into the touch switch PCB. Here for mounting the switch PCB, I am using this same type of black color plastic box, and I have made the holes in the side and used some rubber grommet to pass the wires. Now I will put this PCB inside the box. Now I will put the top cover, and I have also drilled some holes according to the LED positions so we can see the LED from the top of the cover. So we have mounted all the components into the gate. Here is our servo motor, and here is our limit switch, which will tell us the open position, and this limit switch will tell us the close position. And here we have the read switch assembly. In this section we have 2 parts. The right side part is the magnet part. So here you can see we can stick the nose plus into this magnet. The magnet is very strong. And this long part is the read switch part, and you can see the wire coming out from the read switch. So basically this part is for the alignment of the gate. So we have mounted our RFID PCB box into the wall with the help of some screws. Now I will mount the RFID module into this PCB. Here you can see the 3 LEDs on the right side, and now we will put the top cover and fix it with the help of these screws. We have mounted our switch PCB box into the metal gate with the help of some 3mm nut bolt. Now I am going to put the top cover in it, and I will also fix it with the help of some screws. So we have successfully mounted this switch box and this RFID box. Now I will show you the servo based gate lock mechanism, how it will work. So here you can see these metal strips connected with the gate lock, and it is now in the closed position. In this end we have mounted the servo horn, and the servo horn will be mounted on the servo motor shaft, and we are using a M3 bolt to tighten up the servo horn into the servo motor shaft. When the gate lock is closed, it will hit this left side limit switch, and when the gate lock is open, it will hit the right side limit switch. So in this way we are able to know that the gate is open or closed. As this video is getting longer, so I will show you the rest of the assembly in the next part. So this was the part 2 of our IoT based RFID home security project, and if you like this video, then make sure you hit the like button, and if you have any question you can comment down below. And in the next part I will show you the programming and the development of the Android application. So stay tuned for that, and subscribe to our channel and press the bell icon for the upcoming notifications. And if you want to support our effort, then you can buy me a coffee. Link is given in the description below. And the most important thing, be creative.